I'm particularly going to zoom in on three safety concerns or side effect concerns that people hear about creatine. And he's also mentioned that even if creatine does lead to water retention, it's leading to water retention in the places you want it to be. I think probably the big concern when people talk about water retention is that it's going to make you look really bloated and it won't look good aesthetically. 1998 case study that kind of started the snowball of concern around creatine and creatinine levels. So if you remember anything from high school biology, hey, everybody. Welcome to post number one of what I think I'm going to call the Talking Studies series. This will be a series of posts where I'll break down some individual research studies and share some cool findings I've come across while reading through research on a bunch of different health and fitness topics. I think this will be useful, one, because a lot of times when I'm going through deep dives, I'll find individual studies that have really cool or useful findings, but I at most will only dedicate like a couple paragraphs to them, or they'll just be one of the citations kind of buried within the whole deep dive that's covering like the overarching body of evidence. And so this will be a cool way for me to share findings from individual studies. And also, it'll make it a little bit easier for me to share content in general because although I really like the deep dives and there are some benefits and cool takeaways from those, it takes a lot of energy to read through all of those papers and to come away with a conclusion of the overarching body of evidence, like I said. And, I have to read through and edit everything that I'm writing and kind of take care to cover all the nuances and stuff with the wording. This way, it can kind of just be like, sitting down with me once a week or once a month, however often I post these, as if we were just sitting down for coffee or something to talk about some cool research that I've read. So, with that said, I'll kick it off. I decided to start off with a review paper called The Common Questions and Misconceptions About Creatine Supplementation. What does the scientific evidence really show? Because I've talked to a lot of people over the years about creatine, family and friends that have come to me asking me about it, and particularly asking about like safety concerns and stuff like that. So, although this paper covers a handful of kind of common questions and misconceptions, like the title alludes to, I'm particularly going to zoom in on three safety concerns or side effect concerns that people hear about creatine and what this review paper, what the authors have to say about what the actual research talks about or suggests in terms of these safety concerns. But first, I figure it'll be useful to cover what creatine is in general. So, creatine is a compound in your body that occurs naturally, but also you can take in largely through meat. But I think there are also probably some other sources, but the main dietary source of creatine is from meat. And it's useful, particularly from a supplementation perspective, because creatine can act as a phosphate donor. Now, what do I mean by that? So, if you remember anything from high school biology, when we zoom in on a cell, particularly in this case, a muscle cell, the source of energy within that cell is a molecule called ATP, adenosine triphosphate. And really, when we say energy, it's quite literally chemical potential energy. But the way I think about it is just the ability to kick off reactions. Because if we, again, zoom in on that cell, all of the functions and everything going on are largely, or the way I think about it, just a conglomeration of a bunch of different chemical reactions working together to create, net functions. And adenosine triphosphate is particularly useful in this perspective because it has, just like the name implies, an adenosine molecule connected to three phosphates, right? Triphosphate. And those phosphates all are negatively charged. And just like if you took three magnets and put the negative ends of them together, those three negatively charged phosphates are going to repel one another. They don't want to be stuck together. And so the fact that they are stuck together on that molecule of ATP means that it's really easy for that molecule of ATP to bump into another molecule and pass off one of those phosphate groups. And since that phosphate group is negatively charged, it can initiate some type of chemical reaction with that other molecule that ATP is bumping into, and that can set off a cascade of reactions, right? That's, if there's some chemist, PhD listening to this, they're probably upset that I missed some nuances there, but I think that's kind of the general gist of why ATP is useful. Where creatine comes into play is that creatine can get turned into creatine monophosphate. So it can carry or bind to one phosphate group. And so after that reaction we just talked about occurs where ATP gets rid of one of its phosphates. It now becomes ADP, adenosine diphosphate, because now it has two phosphate groups. And creatine monophosphate can come along and donate its phosphate group, right? It's a phosphate donor to replenish the ATP. It can turn the ADP into ATP by giving it or giving it its phosphate group. Why is this useful? Particularly when it comes to athletics or times of high energy demand. This creatine monophosphate system or process where creatine can donate its phosphate group to replenish ATP is useful because as ATP gets used up, there's kind of a gap before the pathways that produce more ATP, like glycolysis and cellular respiration, kind of kick in to fill in and replenish that ATP. The creatine monophosphate system will fill that gap by providing the phosphate to replenish the ADP that's being kind of kicked out or produced as ATP is being used to replenish that ATP store to provide, again, a gap. And this is particularly useful when it comes to kind of high energy demand scenarios. So you think like sports where you're producing a lot of power or a lot of force in short periods of time. So like sprinting or weightlifting, stuff like that. So if we go and start looking at the actual study, quote, creatine methylguanidine acetic acid is the chemical name for it, is endogenously formed from reactions involving the amino acids arginine, glycine, and methionine in the kidneys and liver. Exogenously, creatine is primarily consumed from meat and or as a dietary supplement. According to PubMed, there are over 500 peer-refereed publications involving various aspects of creatine supplementation, end quote. So as the quote talked about there, just like I talked about, creatine naturally occurs. And importantly, there's a lot of research on creatine. It's really common if you listen to kind of big voices in sports science or I guess performance in general. Like if you listen to Andy Galpin, Dr. Andy Galpin, Dr. Lane Norton, Dr. Mike Israetel, people like that, they'll commonly say things like creatine is one of the most consistently shown is one supplement that's been most consistently shown to be effective. There's a lot of research on it, and a lot of it shows that it's useful for kind of the use case I just described. If we move a little bit further on in the study, quote, creatine is converted to phosphocreatine, regulated by the enzyme creatine kinase in muscle, and used to create intracellular adenosine triphosphate production. Creatine supplementation, however, can increase the capacity of ATP and energy produced during heavy anaerobically related exercise, thereby possibly increasing muscle power, repetitions, and exercise volume, which can subsequently contribute to muscle performance and hypertrophy over the course of a training period, end quote. So, like that quote alludes to, the gist is not only that it can help acute performance, but if you add up those acute performances over time, right, if you're trying to build muscle in the gym, if you consider that creatine supplementation could potentially help you get a few extra reps per set over a long period of time, that could lead to some amount of increased muscle growth and increased strength development from your training over time. So now that you understand kind of the use case for creatine, that it can be useful in those kind of sports performance and training perspectives. And from a biological level, you kind of understand where it comes into play in the cell. We can move on to some of the kind of myths or misconceptions or worries that I want to address. And we'll start with creatine and water retention. So, pretty much, there's this myth or this idea that if you take creatine, you'll gain a bunch of water weight or hold on to a bunch of water weight. And to some degree, this is backed up by some of the mechanisms of how creatine moves around in the body. So, when creatine is taken up from the blood into the muscle cell, it is done so via a sodium dependent transporter. So, pretty much as creatine moves into the cell, sodium also moves in with it. And if you remember anything again from high school biology, this will create a gradient where there's more sodium inside the cell than there is in the blood, and that will cause water to move into the cell to kind of balance things out, right? The best analogy I ever heard to kind of explain concentration gradient is if you're at a party with a bunch of people and there are two rooms that are connected. If a bunch of people move into one room, over time it'll get kind of crowded, people will get squished, they'll get really hot, and just naturally people will start to move to the other room where there's more space available, there are less people to kind of balance things out. And then over time, maybe in that second room that people are moving to, it'll start to get crammed again. It'll start to get hot again. And over time, it'll kind of balance out where people will find the room that is less crowded and less hot. And generally, this will lead to kind of an equilibrium where things are kind of balanced between the two rooms. Because one way or another, if people move to one room more than the other, it'll lead to an imbalance that's uncomfortable. So if we go back to what I was talking about with creatine, is as creatine moves into the cell, it pulls sodium into the cell, and now there's a concentration gradient where there's more sodium in the cell than there is in the blood, and this will cause water to move into the cell to kind of balance things out. I know that's a little bit backwards from the analogy I just described, but in general, you understand the point where the body will, or I guess at a cellular level, water will move into the cell to kind of balance things out, right? So there's a balance of solute, in this case, sodium in the cell, and solvent, in this case, water. And so that's where kind of the foundation of this idea that creatine will lead to water retention comes from. Quote, it does appear that the most common adverse effect of creatine supplementation is water retention in the early stages, i.e., the first several days. For example, studies have shown that 3 days of creatine supplementation increase total body water and extracellular body water and intracellular body water. Intracellular water. Unfortunately, based on these short term responses, this notion that creatine increases water retention over the long term has been widely accepted. End quote. So, what the authors are kind of alluding to is that although there is some data to back up that acutely or in the short term, if you take creatine, and as we'll see, particularly if you take a lot of creatine, it could lead to some water retention, but that this doesn't necessarily mean there will be water retention over the long term. If we keep moving on, quote, creatine is taken up into muscle by circulation from circulation by a sodium dependent creatine transporter. Since the transport involves sodium, water will also be taken up into muscle to help maintain intracellular osmolality. However, considering the activity of the sodium potassium pumps, it is not likely that intracellular sodium concentration is dramatically affected by creatine supplementation. End quote. So, what the authors mention here is that although, like I described, due to the concentration gradients, there might be movement of water into the cell. However, although sodium's increasing in the cell with the kind of co-transport of creatine and sodium into the cell, there are also mechanisms, the sodium potassium pumps, that will correct for this. So they'll pump some of that sodium out to correct for that concentration gradient. So there really won't be a huge overflow of sodium or increase in sodium in the cell. And what's important is when we look at actual research studies about this, moving beyond just a mechanism that might explain why there might be increased water retention with creatine consumption, we see that this is not necessarily the case, or at least it's not consistent across several studies. Quote, a number of exercise training studies, for example, those that take 5 to 10 weeks, incorporating creatine supplementation have shown no increases in total body water. For example, resistance trained males who received creatine at a dose of 0.3 grams per kilogram of lean body mass per day for 7 days, approximately 20 grams per day, followed by 4 weeks at 0.07 grams per kilogram lean body mass per day for 28 days, approximately 5 grams per day, experienced no significant change in intracellular water, extracellular water, or total body water. Furthermore, resistance trained males who consume creatine supplementation at 20 grams per day for 7 days, followed by 5 grams per day for 21 days, had no significant increase in intracellular water, extracellular water, or total body water. Similarly, males and females ingesting creatine 0.03 grams per kilogram per day for 6 weeks experienced no significant increase in total body water. 6 weeks of creatine supplementation in non-resistance trained males at a dosage of 0.3 grams per kilogram lean body mass for 5 days, followed by 0.075 grams per kilogram of lean body mass for 42 days, produced no significant changes in total body water. In contrast, when assessing total body water, intracellular water, and extracellular water content before and after 28 days of creatine supplementation in healthy males and females, Powers et al. Showed that creatine supplementation was effective at increasing muscle creatine content, which was associated with an increase in body mass and total body water, but did not alter intracellular water or extracellular water volumes. End quote. So, as you see there have been a bunch of studies that have been conducted to test whether or not creatine consumption does actually lead to measurable increases in total body water or intracellular water, water within the cell, or extracellular water, water outside of the cell. And there are many that show it doesn't. And as you saw, there are some that maybe show it does, but it's a mixed bag, like I kind of alluded to earlier. And one important point is where any water is retained if it is retained. And that's kind of exemplified by this quote. Quote, in a recent study examining the effects of creatine supplementation combined with resistance exercise for 8 weeks, Ribeiro et al. Found a significant increase in total body water by 7% and intracellular water by 9.2% volume compared to placebo, which saw total body water increase of 1.7% and intracellular water by 1.6%. With both groups similarly increasing extracellular water, the creatine group by 1.2% versus placebo by 0.6%. Importantly, the ratio of skeletal muscle mass to intracellular water remains similar in both groups. It is important to highlight that the intracellular water is an important cellular signal for protein synthesis and thus drives an increase in muscle mass over time, end quote. So that last piece I think is important in that the authors suggest that even if there is water retention based on the results from this particular 8-week study, the water retention will likely occur inside the cell, the muscle cell, which is actually useful for potentially growing muscle or maybe performance. Having more water in that cell may be useful in that regard. And this is one thing I've heard Dr. Lane Norton, who's a really well respected voice in the kind of health and fitness uh, communication field, and is also a PhD in sports nutrition, I believe. He's also mentioned that even if creatine does lead to water retention, it's leading to water retention in the places you want it to be. I think probably the big concern when people talk about water retention is that it's going to make you look really bloated and it won't look good aesthetically. When it comes to uh, intracellular water inside the muscle, he argues, Dr. Norton, that this is actually beneficial probably for aesthetics because it'll make the muscle cells look bigger. And again, it may be beneficial for performance. So to wrap it up, quote, in summary, while there is some evidence to suggest that creatine supplementation increases water retention, primarily attributed to increases in intracellular volume, over the short term, there are several other studies suggesting it does not alter total body water, intra or extracellular, relative to muscle mass over longer periods of time. As a result, creatine supplementation may not lead to water retention, end quote. So, in summary, like the author said, there may not be any concern for increased water retention. And even if there is, it's increased water retention in places you probably want it. One caveat here, I guess, is if for some reason you're worried about your total body weight, maybe you're a cyclist or a runner, or for some reason, specifically the actual weight of your body matters to you. Maybe you're, training for like some calisthenics competition or something. It may be useful to not start consuming a bunch of creatine right before competition where it'll make you a lot heavier, and that could be meaningful for like long endurance cyclists or runners where you probably don't want to be carrying any extra weight if you don't have to. Moving on from water retention, I think one of the most common concerns that you'll hear about creatine consumption is that it will damage your kidneys, right? And this, similar to the water retention idea, is rooted in kind of a biological mechanism associated with creatine, or more specifically, the misunderstanding of a biological mechanism associated with creatine. To go into the paper, quote, questions and concerns involving creatine supplementation and kidney damage / renal dysfunction are common. In terms of pervasive misinformation in the sport nutrition arena, the notion that creatine supplementation leads to kidney damage / renal dysfunction is perhaps second only to the myth that protein supplementation and high habitual protein intake causes kidney damage, end quote. So you see there, the authors maybe throwing a little bit of sass at people talking about creatine and kidney issues. Continuing on, quote, today, after more than 20 years of research which demonstrates no adverse effects from recommended dosages of creatine supplements on kidney health, unfortunately, this concern persists. While the origin is unknown, the connection between creatine supplementation and kidney damage / renal dysfunction could be traced back to two things: a poor understanding of creatine and creatinine metabolism, and a case study published in 1998, end quote. So, to address what they're talking about in the end of that quote, a lot of this comes down to creatine and its association with creatinine. So, creatine and phosphocreatine both get broken down in the cell into something called creatinine, which is a compound that goes into your blood, and your kidneys normally will filter creatinine out. And so, creatinine is one protein that's looked at as a marker of healthy kidney function. So, in someone with dysfunctional kidneys, you'll see elevated creatinine because their kidneys aren't properly filtering the creatinine out of their blood. And when you consume a lot of creatine, what you'll see is that your creatinine levels may increase because you're having more creatine, and more creatine is being broken down into creatinine and the levels get elevated in your blood. So, one takeaway here is that, oh, creatinine's elevated, your kidneys might not be working properly because it seems like maybe they're not filtering creatinine out of your blood. Back to the paper, quote, in skeletal muscle, both creatine and phosphocreatine are degraded non-enzymatically to creatinine, which is exported to the blood and excreted in the urine. Healthy kidneys filter creatinine, which would otherwise increase in the blood. Therefore, blood creatinine levels can be used as a proxy marker of kidney function. However, the amount of creatinine in the blood is related to muscle mass, i.e., males have higher blood creatinine than females, and both dietary creatine and creatinine intake. Both blood and urinary creatinine may be increased by ingestion of creatine supplementation and creatine containing foods such as meat. Creatine is normally not present in urine but can reach very high levels during creatine supplementation. There appears to be an unsubstantiated perspective that if the kidneys are forced to excrete higher than normal levels of creatine or creatinine, some sort of kidney overload will take place, causing kidney damage and or renal dysfunction. In reality, transient increases in blood or urinary creatine or creatinine due to creatine supplementation are unlikely to reflect a decrease in kidney function, end quote. So one analogy that I think is useful here is if you think about a house where the paper boy or girl comes along and drops off paper on the front porch every day. If you see the paper building up outside of the door, it may be a marker or a signal that something isn't right inside the house, right? For whatever reason, the people inside the house haven't come out to get their paper. Maybe they got locked in the basement and they can't come out. Maybe they fell and they can't get up, something like that. In many cases, the buildup of paper outside of the house may be a marker that there's something wrong going on inside the house, that something isn't functioning correctly. Maybe the people didn't pay their rent and they got kicked out of the house or something. Now, there could also be other explanations why paper is building up where there is no dysfunction going on in the house. Maybe the people living in the house simply use the garage for entry, and so they don't go through the front door a lot, and they don't see the paper a lot, so they only pick it up once a week, and you may be looking at the paper building up the day before they go out and collect it all, and it seems like there's something going on in the house, but in reality, they've just been using the garage door a lot, right? Or maybe they've been on vacation for 2 weeks, and so it seems like something's going wrong inside the house, but in reality, they're just on vacation. If you think about creatine or creatinine in particular, it, like I said, is a marker of kidney dysfunction because if the kidneys aren't functioning properly, creatinine can build up in the blood because it's not being filtered out. However, the presence of high creatinine in the blood isn't necessarily uh, indicative of kidney dysfunction, right? Because you could just be increasing your creatine consumption, leading to increased creatinine, and that's why it's building up in the blood. Even though it's being filtered out properly, there's just more of it, so it's elevated in the blood, not necessarily indicative of the kidneys not being able to filter it out of the blood. And interestingly, it seems that creatine doesn't always lead to increases in serum creatinine above normal levels when you supplement it or when you're eating more meat. Quote, in a review of creatine supplementation studies, Persky and Rawson found no increase in serum creatinine in 12 studies. 8 studies showed an increase that remained within the normal range, and only 2 studies showed an increase above normal limits, although not different from the control group in one study, end quote. So, as you see, there are there's some research suggesting that creatine consumption doesn't even necessarily lead to increases in creatinine levels. So even if this was some sign of kidney dysfunction, it's not consistent across the board. Then the authors continue on in the paper to address how a 1998 case study that kind of started the snowball of concern around creatine and creatinine levels. Quote, in 1998, a case study of a young male with focal segmental glomerulosclerosis and relapsing nephrotic syndrome was reported. These are both kind of issues with kidney function. The young male who had kidney disease for 8 years and was treated with cyclosporin, i.e., an immunosuppressant, for 5 years, had recently begun ingesting creatine supplementation, 15 grams per day for 7 days, followed by 2 grams per day for 7 weeks. Based on increased blood levels of creatinine and subsequent estimate of calculated creatinine clearance, his kidney health was presumed to be deteriorating, although he was otherwise in good health. The patient was encouraged to discontinue creatine supplementation. At this time, it was already known that blood and urine creatinine levels can increase following ingestion of creatine containing food products, including creatine supplements. This was ignored by the authors of this case study, as was the inclusion of two investigations which demonstrated that creatine supplementation did not negatively impact renal function. The dosage of creatine during the maintenance phase, which was also ignored, was only slightly higher than the daily creatine intake of a typical omnivore's dietary intake, or in terms of food, a large hamburger or steak per day. In response to this case study, two separate teams of experts in creatine metabolism wrote letters to the editor of Lancet. However, the notion that creatine supplementation leads to kidney damage and or renal dysfunction gained traction and momentum, end quote. So they kind of describe how this one case study kind of set off a snowball effect where down the line, people just continued kind of reiterating that creatine was going to be negative in terms of kidney function because it'll raise creatinine levels. But if we look at research thereafter, follow-on research shows that creatine doesn't negatively impact healthy kidneys, which in the last quote, the authors kind of alluded to, but down the line also address how many further studies have shown that this is the case. Quote, since this case study was reported in 1998, experimental and controlled research trials investigating the effects of creatine supplementation on kidney/renal function has substantially increased. Overall, in healthy individuals, there appears to be no adverse effects from consuming recommended doses of creatine supplements on kidney/renal function. Interestingly, Gualano et al. Reviewed a small number of case studies which reported renal dysfunction in individuals who were supplementing with creatine. Similar to the case report by Pritchard and Kalra, these additional case reports were confounded by medications, pre-existing kidney disease, concomitant supplement ingestion, inappropriate creatine dosages, for example, 100 times the recommended dose, and anabolic androgenic steroid use, end quote. So, as the authors describe, there's a lot of research looking into creatine and kidney dysfunction. And when it comes to healthy individuals who have normal kidney function at the get go, creatine does not seem to have any negative implications for kidney dysfunction. There are some cases where it might, but as the authors alluded to, these are kind of outliers where individuals either already had kidney issues or they were inappropriately using creatine using really high dosages, or they had kind of other confounding variables like anabolic steroid use. And the authors also bring up an interesting point, which is that a lot of athletes take creatine. So one question to ask is, where are the bodies, so to speak? If creatine consumption is so bad for your kidney function, where are all these athletes or all these people taking creatine that have really bad kidney dysfunction? And to be fair, we have to remember that absence of evidence doesn't imply evidence of absence, right? Just because there aren't people with kidney dysfunction who have been taking creatine doesn't necessarily mean that this relationship between creatine and kidney dysfunction doesn't exist, but it is one viewpoint to add to the overarching kind of view on creatine and kidney dysfunction. Quote, survey data indicates that creatine supplementation usage ranges between 8 to 74% in athletes and other exercising individuals. Even with a low estimate of 8% of exercising individuals using creatine supplements, this indicates thousands of exposures across several decades. If the link between creatine supplementation and kidney health was valid, there would be an expected increase in kidney damage/renal dysfunction in low risk, i.e., young, physically fit, healthy individuals since 1992 after Harris et al. Published their seminal work. After nearly 30 years of post-marketing surveillance, thousands of exposures, and multiple clinical trials, no such evidence exists, end quote. So again, recognizing that absence of evidence doesn't necessarily mean evidence of absence, it is an interesting point that so many people have been taking creatine for so many years, and there haven't been uh, there isn't evidence of consistent or really notable negative implications for kidney health. And this goes back to what I kind of mentioned in the intro to all of this, which is that there's a lot of research in general looking at creatine. So over all these years, it's likely that if there was a real relationship between creatine consumption and kidney dysfunction, that we probably would have found it. And the authors go on to summarize, quote, in summary, experimental and controlled research indicates that creatine supplementation, when ingested at recommended dosages, does not result in kidney damage and or renal dysfunction in healthy individuals, end quote. Now moving on to our final kind of misconception that we're going to cover. Again, there are a bunch of misconceptions addressed throughout this paper. I think over 10, it might be like 14 or something. I'm just covering a few. Maybe I'll use a follow-on post to cover the others. But here we're going to look at the idea that creatine consumption causes hair loss. And again, this kind of myth or misconsumption uh, is rooted into some mechanistic explanation. In particular, in this case, it's rooted in the idea that creatine supplementation may cause increased DHT levels, and we'll get to what that means. But it's really all based on one study. Quote, the vast majority of speculation regarding the relationship between creatine supplementation and hair loss / baldness stems from a single study by Vander Merwe et al., where college-aged male rugby players who supplemented with creatine, 25 grams per day for 7 days, followed by 5 grams per day thereafter for an additional 14 days. Just to pause, I probably should have mentioned this earlier, but this is like the typical dosage that people would take. Is if they're going to do a loading phase, which is a conversation for another day, they would take, maybe 20 grams of creatine per day for like a week or 5 days, something like that. And then afterwards, indefinitely, they would take 5 grams per day. That's like a pretty standard dosage to be taking. Continuing on with the quote, uh, so these college-aged male rugby players who supplemented with creatine, 25 grams per day for 7 days, followed by 5 grams per day thereafter for an additional 14 days, experienced an increase in serum dihydrotestosterone, end quote. So why does this matter? So dihydrotestosterone, or DHT, is a metabolite of testosterone. So it's another androgen, and it's been linked mechanistically to hair loss. Quote, DHT is a metabolite of testosterone formed when the enzyme 5-alpha reductase converts free testosterone to DHT. In males, DHT can bind to androgen receptors in susceptible hair follicles and cause them to shrink, ultimately leading to hair loss, end quote. So, as far as I understand it, there is a legitimate connection between DHT levels and hair loss. I believe if you look at people who are genetically predisposed to really high DHT, if I remember correctly, they tend to be bald on their head. But interestingly, DHT has a different relationship with hair growth on your face. So, particularly these males who have really high DHT genetically, they'll typically have like really thick beards or facial hair, but no hair on their head. And so, essentially, the whole idea that creatine supplementation will lead to hair loss or baldness is linked back to this one study that didn't look at hair loss, but looked at DHT levels. And since DHT is associated with uh, baldness or hair loss via the mechanisms I just described, there was this kind of alarm that creatine consumption might lead to hair loss. But there are considerable limitations to the study, even beyond what I just mentioned. Quote, however, in the Vander Merwe et al. Study, no increase in total testosterone was found in the 16 males who completed the study. Free testosterone was not measured. Moreover, the increase in DHT and the DHT to testosterone ratio remained well within normal clinical limits. End quote. So if we pause to just look at that, if we look at the results of the whole study, it shows that there were no increases in total testosterone or free testosterone was not measured. And there was also no increase in the DHT to testosterone ratio. And this remained well within the normal clinical limits. So even just looking at the results themselves, it seems like maybe they were blown out of the water a little bit, where there weren't huge differences in these androgen levels anyways. Continuing on, quote, furthermore, baseline prior to supplementation, DHT was 23% lower in the creatine group compared to the placebo group. Thus, the small increase in DHT in the creatine group, in combination with a small decrease in the placebo DHT response, explains the statistically significant increase in DHT noted by Vander Merwe et al. End quote. So, looking at the baseline levels compared to the changes also kind of brings into question whether or not there was a legitimate difference in DHT here. And if we look at follow-on research, like I said, this one study hasn't really been backed up. So, quote, to date, 12 other studies have investigated the effects of creatine supplementation, i.e. doses ranging from 3 to 25 grams per day for 6 days to 12 weeks on testosterone. 2 studies reported small, physiologically insignificant increases in total testosterone after 6 and 7 days of supplementation, while the remaining 10 studies reported no change in testosterone concentrations. In 5 of these studies, free testosterone, which the body uses to produce DHT, was also measured and no increases were found, end quote. So, looking at follow-on studies, it seems like even if there were meaningful increases in DHT, which is kind of questionable from that original study, follow-on studies haven't found or replicated the same results when it comes to creatine supplementation. And at the end of the day, even if they did, we still don't have hard evidence looking at actual baldness or hair loss. And if we go back to what we said before, again, recognizing absence of evidence is not evidence of absence, it would make sense that we'd probably see some, hair loss or increase in baldness amongst athletes or the many people who've been taking creatine for so many years. And in all of the research that we've done, we probably would have seen some effect of creatine on hair loss or baldness at this point. So the authors summarize, quote, in summary, the current body of evidence does not indicate that creatine supplementation increases total testosterone, free testosterone, DHT, or causes hair loss / baldness, end quote. So that wraps up the 3 kind of misconceptions I wanted to pull from this paper. Again, I recommend going and checking it out yourself if you want to see the rest, or if you have some concerns about creatine, you want to learn more about creatine. It is, again, if you listen to people like Dr. Lane Norton, Dr. Andy Galpin, Dr. Mike Israetel, etc., PhDs in nutrition and sports science, they'll consistently tell you, or at least I've heard people like that consistently say, that creatine is one of the most consistently shown to be effective supplements. Geez, I really need to work on the way I'm wording that uh, in the industry, right? And so it might be interesting for you to look into. I've also seen some research coming out in more recent years talking about how creatine might not only be useful for the kind of sports performance cases that I described earlier, but also that it might have beneficial effects on brain health and heart health and all other kinds of things. In particular, I can think, although there might not be huge differences in muscle growth in younger populations, if we look at older populations that are more anabolically resistant or can't grow as much muscle, and have issues with muscle loss, maybe getting that slight increase in muscle growth from creatine might be useful. But all those are kind of topics for another day. In general, I'd say there is some research that I've seen suggesting that creatine in general might be beneficial for health, so it might be something you would be interested in learning about. And that wraps up post number 1 in this Talking Studies series. Feel free to let me know in the comments or anything if you enjoyed this, or if there's any other research you'd like me to share. I've kind of been exploring a bunch of different topics over the past couple of years, so it's likely that whatever you mention, I might have a research paper with interesting findings or something cool to share with you. Otherwise, that wraps it up. Like I said, you can go ahead and subscribe if you want more content like this, regularly throughout your month. And you can also share if you like, if you have someone that you think would benefit from this information. Otherwise, I'll catch you next time.